Beyond our galaxy. Beyond our galaxy. We live in a great big universe. There are literally billions and billions of stars in the universe. However, there's one star located in the center of our solar system called the Sun. There are many different color kinds of stars. Here in this diagram are different color stars: blue, white, red, and yellow. Our Sun is a yellow dwarf star. Stars like our Sun can get very hot indeed. Stars can vary in temperatures. The hottest a star can get is 80,000 degrees Fahrenheit. The coldest a star can reach is 3,000 degrees Fahrenheit. There were two different kinds of models proposed by two famous astronomers concerning what was in the center of our solar system. Our first model is called the Heliocentric Model. The model stated that the Earth, not the Sun, was at the center of the solar system. Greek astronomer Claudius Ptolemy, AD 100 to 170 AD, lived in Alexandria, Egypt. Ptolemy suggested the Earth was at the center of the solar system. The second model here is called the Heliocentric Model. The astronomer in the next picture developed this theory and waited until just before his death to have his book published about this theory. Polish astronomer Nicholas Copernicus, 1473 to 1543. He developed the second model and believes the unpopular belief that the Sun, not the Earth, was the center of the solar system. Copernicus wrote this book titled On the Revolutions of Heavens. This was published just before his death in 1543, but it was the astronomer in the next picture who proved the heliocentric model was correct. Italian astronomer Galileo Galilei, 1564 to 1642. Galileo perfected a telescope and turned it towards the first night object in the sky seen in the next picture, planet Jupiter and its four largest moons. Galileo came to the conclusion that seeing the four small objects orbiting the big one meant that the Copernicus theory being the heliocentric model and that the Sun, not the Earth, was at the center of the solar system. We now will talk about the most important star found in the universe called the Sun. Our Sun is located here in the center of our solar system. Surface temperature alone rises to some 10,000 degrees Fahrenheit. Our Sun gives us Earthlings two things seen in the next two pictures: light to show us the way from where to go from point A to point B, heat to warm up our beaches, and water so we can enjoy being there. The Sun, a hot ball of plasma, size 333,000 times that of Earth. The Sun keeps burning by turning hydrogen into helium, also known as nuclear fusion. Here's what the structure of our Sun looks like. There are 9 layers of the Sun that make it what it is. Believe it or not, the core of our Sun can reach temperatures as hot as 27 million degrees Fahrenheit. Chemical makeup of our Sun: hydrogen 73.45%, helium 24.85%, oxygen 0.77%. Other traces of chemicals are carbon, iron, neon, nitrogen, silicon, magnesium, and sulfur. And just think about this for a moment about the distance of Earth from the Sun. If Earth were too close to the Sun like planet Venus, Earth would be too hot and unbearable to live on it. If Earth were located where planet Mars is, we Earthlings would freeze to death. So just think about how unique Earth is as compared to distances of other planets in our solar system is to the Sun. Another interesting question about the Sun is this: how did the Sun get its name? How did the Sun get its name? The French call it Soleil. The Latin word for it is called Sol. Ancient Romans called it Helios. The Germans call it Sony. The English just simply called it Sun. There are these three things one can study about our Sun. 1. Solar eclipses. 2. Sunspots. 3. Transits. Warning: never, ever look directly at the Sun with your eyes. Always observe the Sun with caution with the next couple of examples. Use cardboard to have the Sun reflected onto it through the telescope seen here in this picture. Here's another example of using cardboard to capture the image of the Sun and look at it safely. Here's an example of using filters to help safely observe our Sun. Here are a pair of filtered sunglasses one can use to safely look at the Sun. These kind of glasses are usually worn during a solar eclipse seen in the next picture. Solar eclipse. A solar eclipse is when the Earth's moon completely lines up the Sun and the Earth, covering most of the Sun. A transit. A transit is when a planet like Venus here passes across the front of the Sun. Sunspots. A sunspot is a spot that appears darker on the Sun as seen here in this picture. Once more, never, ever look directly at the Sun with your eyes. Always use a filter or a cardboard to study our fantastic Sun. On December 2nd, 1998, the space probe called SOHO was launched into space. SOHO was launched into space on this Atlas II rocket. This was a joint venture between ESA and NASA, also known as the European Space Agency and National Aeronautics and Space Administration. SOHO, Solar and Heliocentric Observatory. The mission of SOHO was this: to study the internal structure of the Sun and the massive outer atmosphere and where solar wind comes from. There were 5 other space probes as well that were sent to the Sun and study it. These were 5 other different kinds of space probes that were sent to the Sun to study it as well. We will briefly look at a couple more of these Sun space probes. Space Probe Trace, Transition Region and Coronal Explorer. Launched into space on April 2nd, 1998. Mission: to study the magnetic belts and plasma of the Sun. Cluster 2 Space Probe, an ESA-NASA joint venture mission. Cluster 2 was launched into space on board this Soyuz U frigate rocket in Baikonur, Russia. Cluster 2 launched into space on July 16, 2000 and August 9, 2000. This satellite was launched into space 4 different times. 4 different probes in this mission. Mission: Magnetic Sphere Research of Earth and Sun. We are now going to talk about the next subject of our show: stars. Sun space probe Ulysses weighed 121 pounds. An ESA NASA joint venture mission, operated from October 1990 to February 1992. Mission: measurements of Sun from polar orbit. Ulysses space probe was launched on board the Space Shuttle Discovery. It was launched on October 6, 1990. Ulysses was released in low Earth orbit so it could journey towards the Sun. Here are some of the parts of the Ulysses space probe. The antenna was always pointed towards Earth. Our next Sun space probe is called Parker Solar Probe. The Parker Solar Probe. Launch date: it will be sometime in the year 2018. It will be launched into space on board this Delta IV rocket. The mission of the Parker Solar Probe will be to study the outer corona of the Sun. The probe is a heliophysics orbiter. This space probe will get as close as 4 million miles from the Sun to study it. The Parker space probe will experience an intense heat and radiation from the Sun like no other space probe has ever done before this one. Here are some of the instruments that will be a part of this Parker space probe. The patch says it all about the Parker Solar Probe will do when it is launched in 2018. Our fifth and final Sun space probe we now will look at is called ACE, Advanced Composition Explorer. ACE was launched into space on board this Delta II rocket. It was launched on August 25, 1995. ACE, an orbiter around the Sun. Mission: to collect and analyze particles of solar, interplanetary, interstellar, and galactic origins. It also will span energy ranges from solar wind ions to galactic cosmic rays. ACE will study solar wind to help us understand how this affects us Earthlings back on Earth. Here's the patch symbol for a space probe. The space probe is expected to operate until the year 2024. Indeed, our Sun is a fascinating star to study. Here are some safe pictures one can enjoy viewing of the Sun. So just sit right back down in your easy chair, relax, and enjoy. There are literally billions and billions of stars found in our big universe. The definition of a star is this: they are a giant luminous sphere of plasma. A star is an ionized ball of plasma made up mostly electrons and ions moving around in the way of electric current. Stars begin their life cycle in the form of gas and dust. There are many different colors of stars found in the universe as well. 1 red, 2 blue, 3 orange, 4 green, 5. Yellow. Our Sun is a star located in the center of our solar system. The Sun is a yellow dwarf star. Here is a life cycle of a star and the different colors they go through. Here is a star diagram called HR diagram, also known as the Hertzsprung-Russell diagram. The chart diagrams the sizes and colors of different stars in the universe. Astronomers in the next two pictures developed this diagram independently of each other. Danish astronomer N.J. Hertzsprung, 1873 to 1967. Field of study, astronomy, chemistry. American astronomer Norris Russell, 1877 to 1967. Field of study, astronomy. Stars can be found in what is called the main sequence of stars. Whatever color the star is, one can locate it in the main sequence here. The star in the next picture is an example as to how to locate one in this chart. The star here is called Sirius B. Sirius B is a white dwarf star and a double star as well. Sirius B can be found in the bottom part of the chart. Temperatures of stars vary as well. Temperatures can be as hot as 80,000 degrees Fahrenheit to as cold as 3,000 degrees Fahrenheit. Just think about our Sun. The surface of the Sun's average temperature is 10,000 degrees Fahrenheit. As mentioned earlier, there are different sizes and colors of stars in the universe. The next picture shows sizes and colors of different stars. Here is a comparison picture of star sizes and colors. Imagine for a moment that the star Albireo is our Sun. Albireo would simply overwhelm us Earthlings. There are these different sizes of stars. 1 supergiants, 2 giants, 3 dwarfs. The next 3 pictures are examples of these stars. A dwarf star. A dwarf star is one that is small in size and low in brightness. Our Sun is a yellow dwarf star. Here is a picture of a giant star in comparison with our own Sun. A giant star is a star much bigger in size and brightness than a normal star. Here is a picture of a supergiant type of star. A supergiant star are bigger and brighter than giant stars are. Here's the comparison size with that of our Sun. We now will take a brief look at these 4 different types of stars. 1 double star, 2 variable star, 3 clusters, 4 nebula. The next few pictures are examples of these kind of stars. Double stars. Stars that are physically close together like these are. The mysterious double stars, like this one, is an example. Variable stars. A star which brightness continues to change in regular and irregular ways. Cataclysmic variable star located in a wormhole system is an example of this kind of star. Star clusters. A star cluster star clouds are a group of stars located together. Pleiades star cluster here in this picture is an example of star clusters. Nebula. A nebula is an interstellar cloud of dust, hydrogen, helium, and other ionized gases. Eagle Nebula located in the Pillars of Creation are an example of this one. Here are 3 examples of stars found in different constellations. 1 VY Canis Majoris, 2 Betelgeuse, 3 Polaris. VY Canis Majoris is a hypergiant star located in the constellation of Canis Major, located about 3,500 light years away from the Earth. A semi-regular variable star that can only be seen with a pair of binoculars or telescope. Constellation Canis Major, shaped like a dog. Can you locate VY Canis Major here in this picture? A Class M star. Imagine this. VY Canis Majoris located in the center of our solar system like our sun. The boundary of this star would reach out as far as planet Jupiter. The Star Polaris, also known as the North Star, located in a constellation called Ursa Minor or Little Bear, also known as the Little Dipper, a sea-fed variable star that has periods of times when brightness becomes dim, located 434 light years away from Earth. Here's where Polaris is located on the upper handle of its handle. Here's another picture of Polaris and where it is found in the Little Dipper. Our third and final star we will briefly talk about is found in a constellation called Orion the Hunter. Our star we are looking at is called Betelgeuse. Betelgeuse is an orange-red type star. It is located about 640 light years away from Earth. Betelgeuse average temperatures can be 3,500 degrees Fahrenheit. Betelgeuse is the second brightest star in Orion, with Rigel being the first brightest. Here's a comparison picture of Betelgeuse and two other popular stars. Indeed, we Earthlings would be truly overwhelmed by the sheer size of Betelgeuse. Indeed, studying the stars can be a lot of fun when looking at them through a pair of binoculars or telescope. Here are some awesome pictures of stars to sit right back down in the easy chair, relax, and enjoy. Indeed, there are awesome things to see in the night sky, but only time will tell what we Earthlings will find when we look up into the night sky and beyond our galaxy.